Hi, I welcome again for time and work related problems. So we are again doing previous year questions. The first question is from previous year RBI. 12 men can finish a project in 20 days. 18 women can finish the same project in 16 days. 24 children can finish it in 18 days. Now, 8 women and 16 children started the work and they worked for 9 days and then left. In how many days will 10 men can complete the remaining project? Now, first let's find the individual efficiency of men. What do you mean by individual efficiency? 12 men can finish it in 20 days, right? So, we need to find out one man can finish how much work in one day. That is a man's efficiency. So, let's write it as M dash. M dash is one man's one day's work is M dash. That can be found by 1 by 20 into 12. Why? See, if it was just a man can complete in 20 days, the efficiency would be 1 by 20. But now it is completed by 12 days, right? So we are writing it as 1 by 20 into 12. Similarly, women's efficiency is 18 women completed in 16 days. So 1 by 18 into 16. Similarly, children's efficiency is 16 children work, 24 children can finish it in 18 days. So 1 by 24 into 18. Now we have individual efficiencies. Now let's use this and see how much work was completed by 8 women and 16 children in 9 days. How do you find that? 8 women. See, one woman can finish 1 by 18 into 16 of the work. So, one woman, 1 by 18 into 16 of the work is completed by one woman. But there were 8 women something, right? So, this into 8. So, I am writing it directly as 8 plus 16 children work. Each children will complete 1 by 24 into 18. This is the work done by each children in one day per children. But we have 16 children. So I multiply this with 16. So I'll get 16 on top. Now they did work for one day. They work, see this is 8 children, 16 children and 8 women. Each of them work for 9 days. So I'll multiply 9. Children also work for 9 days and women also work for 9 days. Now let's simplify and see. 9 ones are 9 twos are 8 ones are 8 twos are 9 ones are 9 twos are 8 twos are 8 threes are, right? And this 2 gets cancelled. We are left with 1 by 4 plus 1 by 3 is equal to 7. 4 plus 3 7 divided by 12. So, in these 9 days, 8 women and 16 children completed 7 by 12 of the work. So, how much work is remaining now? The remaining work is equal to 5 by 12. See, out of 12 pieces, 7 is completed. So, only 5 is remaining. Right? Now, this has to be completed by 10 men. Now, let's see. See, one man can complete how much work? One man can complete 1 by 20 into 12 of the work. But now we have 10 men. So 10 into 1 by 10 into 1 by 20 into 12. This much work is completed. This much work will be completed by 10 men in one day. But how much work they have to complete? 5 by 12. Let's divide 5 by 12 of the work with this 10 men's work in one day. Okay. So let's divide this by this. So what do we get? I write here this work 5 by 12 must be divided by 10 into 1 by 20 into 12. So this can also be written as 5 by 12 into this. I will write in reverse. 20 into 12 divided by 10. So 5 ones are 5 twos are. This 2 gets cancelled 10 times. This 12 gets cancelled. So is equal to 10 days. So that work is divided with so much of 10 hours. So they can complete this work in 10 days. Okay, we have another question from our PRE. 16 men and 12 women can complete their work in 8 days. If 20 men can complete the same work in 16 days, in how many days? 16 women can complete the same piece of work. The options are 12, 8, 10 and 15. So now 16 men and 12 women together we have their efficiency as 8. So 16 men plus 12 women can complete the work in 8 days. So that together their efficiency will be what? 1 by 8. Correct? Because in 8 days they complete the complete work. So in 1 day they complete 1/8 of the work. Right? And 20 men can complete the same work in 16 days. So in 1 day they do 1/16 of the work. Clear? The question is, in how many days 16 women can complete the same work, same piece of work. Now, in order to find it, we need to see what is the efficiency of women. One woman's 1 day's work, if you find out, then we just have to multiply with 16 to get the work completed by 16 women. So how do we find that? See, the simplest thing is, see here we can find men's efficiency, into one man's efficiency, we can replace it here and we can get the value of one woman's 1 day's work. Okay, so here from this equation we can find m is equal to, or m dash, whatever we normally put it in this dash, right? So m dash is equal to 1 by 16 into 20. So this is one man's 1 day's work. So if you multiply this with, if you substitute this here in the first equation, then it becomes 16 into 1 by 16 into 20 plus 12 women's efficiency we don't know, we'll leave it as is equal to 1 by 8. Right? So this 16 gets cancelled. So what we are left with is 12 W dash is equal to 1 by 8 minus 1 by 20, which is equal to 20 minus 8 is 12 divided by 160. So women's efficiency is equal to 12 by 160. This 12 I will take it in the denominator and this gets cancelled. So it's equal to 1 by 160. That means one woman can do 1 by 160 of the work. So how about 16 women then? 16 women can do 1 by 160 into 16. 16 ones are 16 tens are. So 16 women can complete their efficiency is 1 by 10. That means 1/10 of the work they complete in 1 day. That means in 10 days they can complete entire work. So they can complete entire work in 10 days. Right? This is okay. Here is another RBA, previous year RBA question. A project requires 12 women to complete it in 16 days. That means 12 women can complete it in 16 days. 12 women started working, but after a few days, we don't know how many days, but after a few days from the start, 4 women left the job. So we don't know how many days after they left, but the remaining work was completed in 18 days. So in how many days the total project was completed is the question. We have 4 options: 24 and a half, 26, 22, 21 and a half, and 25 options. So let's see. 12 women could have finished it in 16 days. Okay, but 12 women started working after some days. We don't know how many days that is. 12 women started working, but after some days, 4 left. So only 8 women work for remaining 18 days to complete the work. Correct? Now we need to know how much work was completed during this duration, so that we can know what percentage of work was completed in first few days. See, 12 women can complete it in 16 days. That means women's efficiency is what? 1 by 12 into 16, like previous thing. If it was just 1 woman can complete in 16 days is 1 by 16. So since it's 12 women, it is 1 by 12 into 16. Right? But here we had 8 women working for 8 women work for 8 women work for 18 days. 8 women work for 18 days and their efficiency was this. So let's say how much work was completed. 8 ones are 8 twos are here, 2 ones are 2 nines are 3 threes are 3 fours are. So 3/4 of the work was completed in these 18 days. So obviously the few days that they were told, only 1/4 of the work was done. 1/4. Right? 1/4 of the work was done in the first few days. To complete the entire work, 12 women take 16 days. So to complete 1/4 of it, 1/4 of the days, that is 4 days. In 4 days they can complete 1/4 of the work, right? So this 4 days plus this 18 days is equal total 22 days. The whole work was completed. So C is the option. Okay, we have another RRB previous year question. Sorry, RBI. B is 4/3 times as efficient as A. If A can complete 5/8 of the given task in 15 days, what fraction of the same task would remain incomplete if B works on it independently for 10 days? So what they're saying is, see, B's efficiency is 4/3 times of A. So that's one thing we know. And if A can complete not the whole work, just the 5/8 of the given task in 15 days, then we know A's efficiency. From A's efficiency, we have to find B's efficiency. Then we should find B need to complete the entire work. He just worked for 10 days. So we need to find out what is the remaining amount of work that is not completed. Got it? So let's start here. See, the efficiency of B and efficiency of A. Efficiency of B is 4/3 is to 1. So if efficiency of A is 1, then efficiency of B is 4/3. Right? This can also be written as, see, efficiency, we can multiply both sides by 3. So it will be 4:3. So this is efficiency. Efficiency. So what is the relationship between efficiency and the time taken to complete the work? Time taken to complete the work. Complete the work. These are inversely proportional. So time will be in the ratio of 3:4. If the efficiency is 4:3, then the time taken will be 3:4. Right? So this is first thing. Now let's find out A's efficiency. A's efficiency is what? He completes not the whole work. Suppose if A completes the whole work in 15 days, it will be 1/15. But he didn't complete the whole work. He just completed what? 5/8 of the work in 15 days. So his efficiency will become what? 5/8 into 15. 5 ones are 5. So 1/24 is his efficiency. That means what? If you give 24 days, he can complete the entire work. If A gets 24 days, he can complete the entire work. If A gets 24 days, he can complete the entire work, right? That means B can complete the entire work in 18 days. So that's the ratio, right? 3:4 ratio. If A can complete entire work in 24 days, then B can complete it in 18 days. Now we know if B had got 18 days, he could have completed entire work. But how many days did he get? He got only 10 days. So what you see, if if B can complete entire work in 18 days, that means his 1 day's efficiency is 1/18. But he worked for 10 days, right? He worked for 10 days. So he would have completed how much? 5/9. So 5/9 of the work he would have completed in 10 days. In 10 days, 5/9. So what is remaining? 4/9 is not completed by anyone. So the what the remaining incomplete work is how much? 4/9 of the work is not completed. So where is the option? Okay, 4 by 2. This is right. Okay, we have similar question here from RBI again. B is 1.5 as efficient as A. If A can complete 6 by 7th of the work in 12 days, what fraction of the same task would remain incomplete if B works on it independently for 6 days? See what he is saying is, see now he has not given efficiency directly, he has given the ratio of their efficiencies. Efficiency of B is 1.5 efficiency of B and ratio, B and A. It is 1.5. 1.5 means we can write 3 by 2. So this is 3 by 2 and this is 1. Okay. And if A can complete 6/7 of work, not the whole work. If we complete whole work, it will be 1 by 12 is the efficiency. Since it's not doing only 6 by 7 of the work, the efficiency of A will be what? If he had completed whole work, it will be 1 by 12. But he has not completed whole work, he just completed 6 by 7 of work. Right? So 6 ones are 6 twos are. So its efficiency is 1 by 14. That means if you give 14 days, he can complete entire work. Okay. If you give 14 days, he can complete entire work. This is efficiency. The time taken would be what? Time taken would be reverse. Time taken would be inversely proportional. So 1 is to 3 by 2. Okay. Or I can write it as 2 is to 3. Okay. If it takes 3 amount of time, he would take 2 amount of time. Okay. So if he is taking 14 days, can you break this directly? 14. This looks difficult. So what I would do is, I would write reverse again. 2 by 3 is to 1. Right. That means if it takes 14 days, B would be taking how much? 2 by 3 times of that 14 days. What is 2 by 3 times of 14? 28 by 3. So if A takes 14 days to complete the work, B would take 28 by 3 days to complete. Okay? He did 28 by 3 days, but how many days he got to work? He got 6 days to work. So let's see what the individual efficiency. This is the number of days he takes to complete the work. That means his efficiency is 1 by 28 by 3 is the efficiency of B, which means it is equal to 3 divided by 28. So he completes 3 by 28 of the work every day, but he got 6 days to work, right? He got 6 days to work. So 6 days when you work, 2 3s are 2 14s are, so it's equal to 9 by 14. So when he got 6 days to work, he completed 9 by 14 of the work. 9 by 14 of the work is completed. So what is the remaining work? 5 by 14. So remaining work is what? 5 by 14. So D is the right. Okay, we have a slightly different question this time. It's from previous year RBI. The work can be finished in 14 days by 36 workers. The work were to be finished in 8 days. How many additional workers would be required? Okay, see, we have individual workers efficiency. If you give 14 days, 36 workers can complete it, but they don't have so many days. They just have 8 days to complete. So they will find how many additional workers are required. So individual efficiency of workers is what? 36 workers can finish within 1 by 14 is the efficiency of 36 workers. Okay. So efficiency of each worker is what? 1 by 14 into 36. This is the efficiency of each worker. Now we have 36 workers plus some workers are joined, and let's assume it's completed in 8 days. Let's find out how much is that. So 36 workers were there. So the efficiency of their work is 1 by 14 plus, let's say there was some X amount of workers added, and their efficiency is all the same. What is their efficiency? Is 1 by 14 into 36, right? And if they complete the work in 8 days, their total efficiency will be 1 by 8. Correct? Now let's solve this. X is equal to, or let's keep this here x and 1 by 14 into 36. Let's keep it left side and we'll take this right side. So it becomes 1 by 8 minus 1 by 14, which means 14 minus 8 is 6, 6 by 8 into 14. Let's not simplify now because anyways some terms that needs to be cancelled. So let's write here x is equal to, let's take this right hand side, so this goes to the numerator. It will be what? 14 into 36 in the numerator, and there is already 6 in the numerator there, and the denominator will be 8 into 14. So 14, 14 gets cancelled, and 4 2s are 4 9s are 2 1s are 2 3s are, so 27. That means 27 extra workers were joined to finish this work in 8 days. 27 is the right answer. Okay, we have another interesting question here from previous year RPA question. The part of the work done by A in 1 day is 1/5 of the part of the work done by B in 1 day. A's 1 day's work is 3/4 of C's 1 day's work. C alone can complete the work in 24 days. So in how many days will B alone do the same work? So now we only have C's efficiency figure given clearly, that C can complete the work in 24 days. Others are given in fractions like A and B. What is A and B's efficiency? A's efficiency is 1/5 of B. If B does it in 1, then A is 1/5 of it. Or you can also write it as 1:5. Right. Next, A's 1 day's work is 3/4 of C's work. Okay. If C does it in 1 day, he will do it in, sorry, if C's efficiency is 1, then A's efficiency is 3/4. Okay, this can also be written as 3:4. So this is about efficiency. Time is reverse. The time taken will be inverse. So if A takes 4 days, then C will take 3 days. But we know C took 24 days to complete the work. Right? If C takes 24 days, then A would take more. So how much? 8 3s are 24, 8 4s are 32. So A would take 32 days to complete the work. But our question is, in how many days B will take to complete the same work? If A takes 32 days to complete, how much does B take? A takes only, see, 1:5 is the efficiency ratio. The time ratio would be reverse of it. That means if A takes 5 days, B would take only 1 day. Right? So now we have 32 days as A's time. Then B would be 32 divided by 5. 32 divided by 5. That means 5 6 are 32, and remaining 2 will be divided by 5. 6 2 by 5. We have 6 2 by 5 as the right. Okay, we have another good question here. A alone can complete a piece of work in 42 days. B is 20% more efficient than A, and C is 40% more efficient than B. In how many days B and C working together can finish the same work? Okay, let's see. The efficiency of A is known. He can finish complete work in 42 days. That means A's efficiency is 1/42. That means he finishes 1/42 of the work in 1 day. What is B's efficiency? B's efficiency is 20% more. What is it mean by 20% more? 20% more, see, you can write it as 20% like this, or this if you actually simplify 1/5. Right? So 1/5 more than A. So it becomes 6/5 is 20% more means 120%, right? If this is 100%, this is 100%, this is 120%. So we write it as 6/5. So 1/42 into 6/5. This is B's efficiency. Now what is C's efficiency? It's 40% more. C's efficiency is 40% more. What is 40% more? See, 20% is 1/5, right? So we added 1 to get 20% more. If you add 2 times, then we get 2/5 as 40% extra. Like 5 is 100%, then 7 is 40%. So 1 by 42. See, it's 40% more than B, right? So first we'll write what is B's efficiency. This is B's efficiency. Now 7 by 5 is multiplied with that to get 140% of this is 100%. This is 120%. So this is 140% of this, 40% more. Okay, now we have individual efficiency for all three. Now if B and C are working together, in how many days they can finish their work? Let's take this. If they are working together, efficiency of B plus C is equal to 1 by 42 into 5 or 6 by 42 into 5 plus here 6 into 7 divided by 42 into 5 into 5. Okay, let's simplify wherever possible. 6 ones are 6 sevens are 6 ones are 6 sevens are the 7 gets cancelled here. Okay, so it is 1 by 35 plus 1 by 25, right, is equal to 25 plus 35 is 60 divided by 25 into 35. You can further simplify this. 5 12s are 5 5s are that's it. Okay, so it is 12 divided by 35 5s are 175, right? Okay, so this is the efficiency of B plus C. That means they can finish the entire work in inverse of this 175 by 12 days. So the options are in this way. So let's further simplify this. 12 ones are 12. We have another 55 there. So 12 fours are 48. So we have another 7 left. 7 further cannot be divided. So 7 divided by 12 is 14. 7 by 12 is the right answer. Okay, we have another interesting question here from previous year RBI questions. A project manager hired 16 men to complete a project in 38 days. However, after 30 days, he realized that only 5/9 of the work is complete. How many more men does he need to hire to complete the project on time? Means already 30 days are passed, only 8 days are remaining. So now he needs to hire more people so that another, say out of total work, 5/9 is complete. That means the remaining work is 4/9. To complete 4/9 of the work, he need to hire additional workforce or additional men so that he can complete it in remaining time, which is out of 30 days is already passed. So only 8 days is left. So let's see how many more he has to hire. So let's find the efficiency of men first. See here 16 men work for 30 days. Work for 30 days. 60 men work for 30 days, but how much work did they complete? 5/9, not the complete work. Only 5/9 of the work they completed. That means the efficiency of each man is 5 divided by 9 into 30 into 16. Right? So 5 ones are 5 6 are, which means this is what 1 divided by is 54. Let's not simplify further. Some numbers gets cancelled anyway, so let's not waste time here. So just note the efficiency of men as 1 by 54 into 16. Now with this efficiency, let's see how many number of resources or how many men are required to complete the remaining work. What is the remaining work? The remaining work is, let's say he uses X number of people to complete that work with the efficiency, X men with the efficiency of 1 by 54 into 16. let's say he uses that force to complete that remaining work. What is that remaining work? Out of, see, out of 9, 5 is complete. So that means remaining is 4 by 9. He has to complete this in how much time? Only has 8 days left. Correct? Okay. Now let's simplify. Now x is equal to what? X is equal to 4 divided by 9 into 8. This goes to the numerator. So 54 into 16. 8 ones are 8 twos are. What else? 9 ones are 9. 6 are. So 4 into 6, 24, 24 into 2 is 48. So total when required is 48. But he already had 60 people working with him already, right? So let's minus that 16. He already has. So it's 2 and 3, 32. So he needs 32 men, extra 32 men to complete that project on time. So option C, 32 is the right answer. Okay. We have another question here from SSC CGL. SSC CGL. A, B, C can complete the work in 10, 12 and 15 days respectively. A left the work 5 days before the work was completed. That means when in the last 5 days, he did work for last 5 days. And B left 2 days after A left. The number of days required to complete the whole work is, see, A, B, C started working. A, B and C, all three started working. And when 5 days were remaining to complete the work, just before 5 days, A left. So only B and C started to work. And after A left, in another 2 days, B also left. So only C worked for remaining days. That means here it was 2 days and this is 3 days. Clear? A, B, C started working. So we don't know this is the X number of days. We don't know how many days there is this. So A, B, C started to work together and after some days B left when 5 days was remaining. So only B and C worked for 2 days. After 2 days, because B also left after 2 days, so only C was working for last 3 days. Now, see the efficiency of them is 1 by 10, 1 by 12 and 1 by 15. See, let's assume the total work as LCM of these three numbers, 10, 12 and 15. How do you find LCM? See, usually when you have three numbers, the LCM will be the largest of those or multiple of the largest number. See, because 15 is not divisible by 10 or 12, so it has to be either 60 or 30 or 60 like this. You can try some numbers, so easily you can find 60 matches with this. So this is the easiest way to find, or you have to do 10, 12 and 15. You divide it with like let's say 2, 5, 6. Sorry, oh yeah, this cannot be divided. Again with 5 you try 1, 6 cannot be divided, and 3. So this way you can find. Then also you get the same 60 as LCM. Okay. So since 60 is the LCM, we can assume the total work to be 60. If total work is 60, the total work is 60. Then let's see what is the efficiency of A. Efficiency of A is 1 by 10, because he can complete the entire work in 10 days. So his efficiency is 1 by 10. Efficiency of B is 1 by 12, and efficiency of C is 1 by 15. The total work to be done is 60 units. So with that efficiency, if 60 work has to be completed in 10 days, it's not 1. So let's assume it is 60 is the total work. It's not 1. If 60 is the total work, then the efficiency becomes 6 here. That means every day he does 6 units. Total work to be done is 60 units. So he does 6 units of work every day. 6 units. It can be anything. Building 6 houses or working 6 kilometers, walking 6 kilometers, whatever. 6 units work. And here it's 12 on the 5 zone. So 5 units of work is his efficiency per day. And here it is 4 units of work. So C does 4 units of work every day, B does 5 units of work every day, and A does 6 units of work every day. Now C worked for 3 days, we know. So 3 days he would have completed 12 units of work, correct? And B and C together they work for 2 days. So 5 plus 4. Every day they do 9 units of work, and into 2 is 18 units of work is completed here. So total work is 60. In that 30 is completed here. So the remaining work is 30. So 30 units of work is remaining, and together they can, all three are doing it. Then 6 plus 4, 10, 10, 15. So 15 units they can do in one day. So 30 units is pending. So they can finish this in 2 days alone. So 2 days here, 2 days here, and 3 days here. So total is 7 days. 7 days is the right answer. Okay, we have another SSC question. A can complete a piece of work in 10 days, B in 15 days, and C in 20 days. A and C worked together for 2 days, and A was replaced by B. In how many days altogether the work was completed? See, A and C started the work. A and C started the work. They worked for 2 days. 2 days. Then A was replaced with B. So then the remaining time was worked by B and C. So we don't know how many days they worked. Okay. Now let's see the individual efficiency of A, B, and C. See here, A can complete the work in 10 days, B can complete it in 15 days, and C can complete it in 20 days. Let's take LCM of that as the total work. So 10, 15, and 20. 10, 15, and 20. So the LCM is 60. How do we get it? We'll take the highest number, and if these numbers are not divisible by that, then we'll double it. 40. So 15 is not, 40 is not divisible by 15. So let's try 60. So 60 is divisible. So we'll take 60 as a LCM. So if total work is 60, now total work, let's assume total work as 60 units. Okay, let's assume total work as 60 units. Now let's see how many units of work A does. A's efficiency is what? The total work he can complete it in 10 days. That means 6 units he can do every day. Right? What is B's efficiency? B can complete the total work in 15 days. So every day he does 4 units of work. Okay? And C, he complete entire work in 20 days, right? So he does 3 units of work every day. Now when A and C started working, they could complete A and C together. They would work. They complete 9 units, and they work for 2 days. So here they completed 18 units of work. So how much is remaining out of 60? 42, right? 42 units is completed by B and C. B and C together how much they do? 7 units every day. So 7 units per day, and they did 42. So 42 divided by 7 is 6. So it is 6 days they work together. So total altogether, how many days the work was completed? 6 days plus 2 days is 8 days. Okay, so option B, 8 days is the right answer. Okay, next question is A can complete a piece of work in 18 days, B in 20 days, and C in 30 days. B and C together started the work and are forced to leave after 2 days. So B and C both left the job. The time taken by A alone to complete the remaining work is, okay, B and C work for 2 days, and the remaining time is this one is worked by A alone. Both left after 2 days, right? Let's see. Now we need to find the time taken by A alone to complete the remaining work. So now we need to find this value of x days there. Right. A can complete in 18 days, 20 days, and 30. Let's find the LCM of that, and let's assume them as a total work. 18, 20, and 30. Usually, like the way I said, the largest number or multiple of that would be the LCM. So you can trace it. 18. 18 is not divisible. 30 is not divisible by 18. So let's find this has to be a round figure, right? So 18 5 is a 90. Let's try 90. 90 is not divisible by 20. So let's say double of that, 180. 180 is divisible by all of. So 180 can be the LCM. So let's assume the total work as 180 units. Okay. Let's assume total work is 180 units. Then let's find the efficiency of A. Efficiency of A is what? The total work is 180. That is finished in 18 days. So 10 units per day. It is 10 units per day. Be it building 10 houses, be it running 10 kilometers, whatever. Similarly, efficiency of B is what? 180 units he completes in 20 days. So 9 units. Right? C's efficiency is 180 divided by 30. 6 units. Right? Now B and C started the work, right? B and C together they can complete 50 units of work in a day, and they work for 2 days. So 30 units of work is completed here. 30 units is completed here. So the remaining work is out of 180, 30 is done. So 150 units is remaining. So total A has to do 150 units of work. He can do 10 units in 1 day. So to complete 150, obviously he needs 15 days. Right? 15 days is the time. Okay. Next question from SSC again. A can do a piece of work in 20 days, B in 30 days. They work together for 7 days and then both leave the work. Then C alone finishes the remaining work in 10 days. In how many days will C finish the full work? See, A can do it in 20 days and B in 30 days. Let's take the LCM of 20 and 30. So it is 60. Because 30 is not divisible by 20, so 60 can be the LCM. So let's assume so 60 units of work has to be done. So efficiency of A is what? Efficiency of A is equal to 60 is done in 20 days means 3 units. Okay, and efficiency of B is 60 divided by 30, which is 2 units. So A and B they work together for 7 days. That means in 7 days, every day A and B can finish 5 units of work, and in 7 days they can finish 35 units of work in 7 days. Units in 7 days. Right. So what is remaining out of 60? Remaining is 25 units is remaining. Which is completed by C in 10 days. C completed 25 units in 10 days. Okay. So C completes 25 units in 10 days. Then if he has to do all 60, in how many days he can complete? Just cross multiplication. Let's say this Z says, so x is equal to 60 into 10 divided by 25. 5 2s are 5 5s are 5 1s are 5 12s are 24. Okay, 24 days is 24 days C can complete full work. So C is the option. Okay, here is the next question. X can do a piece of work in 24 days. When he had worked for 4 days, Y joined him. If complete work was finished in 16 days, Y alone can finish that work in how many days? The options are 18, 27, 36 and 42. See, X started a work and worked for 4 days, and then Y joined him. And the total work was finished in 16 days. That means they worked together for 12 days. Right? The efficiency of X is what? He can finish entire work if he get 24 days. But X worked here for all 16 days. The efficiency of X is equal to, he can finish entire work in 24 days. That means 1 by 24 is his efficiency, and he worked for 16 days, right? He worked for 16 days. The efficiency of X is 1 by 24 and X worked for 16 days. So 4 4s are 4 6 are 2s are 3s are. So 2/3 of the work was completed by X. 2/3 of the work was completed by X. So Y completed 1/3 of the work. Y completed how much? 1/3 of the work is completed by Y. And to complete 1/3 of the work, he took 12 days. So to complete 1/3 of the work, he took 12 days. And if he has to complete whole one work, then he will take how many days? Let's say X days. So cross multiply X is equal to 12 divided by 1 by 3, or 12 into 3 is equal to 36 days. 36 days is a reference. Okay, we have another question from SSC, CGL. If 6 men and 8 boys can do a piece of work in 10 days, and 26 men and 48 boys can do the same work in 2 days, then the time taken by 15 men and 20 boys to do same type of work will be, the options are 5 days, 4 days, 6 days and 7 days. Okay, 6 men, let's take 6M, 6 men and 8 boys together, they work for 10 days to complete a job, and 26 men and 48 boys work together for 2 days to complete the same job, right? Or okay, let's see how this came. See, normally how we write 6 men plus 8 boys complete the work in 10 days, right? So so 1 is equal to this 10. If you take here 10 into 6M plus 8B is equal to 1, right? Similarly, if you write 26 men and 48 boys do the work in 2 days. So if you do the same thing, 2 into 26M plus 48B is equal to 1. So both are equal, right? That's why we have written like that. Okay. So we have 10 into 6M plus 8B is equal to 26M plus 48B into 2. Let's simplify this to find the value of the relationship between M and B. So let's simplify. So 26. Okay, let's see like this. 60M plus 80B is equal to 52M plus 96B. Okay, so let's take B on the right hand side, let's take M on the left hand side. So 60 minus 52 is 8M is equal to 96 minus 8 is 16B. That means M is equal to 2B. So every man's work is equal to 2 times of boy's work. Right. Now let's substitute this in one of those equations, like maybe left hand side or right hand side. Let's take one of those. So 10 times of 6 men. Instead of 6 men, let's take it as 12 boys, because M is equal to 2B. So 12 boys plus 8 boys is equal to 1. Right? So it's 20, 12 plus 8 is 20, 20 to 10 is 200B is equal to 1. That means efficiency of boy is 1 by 200. That means one boy does in one day 1 by 200 of the work. Now the question is what? 15 men and 20 boys can do the same work in how many days is the question. So instead of 15 men, let's say 30 boys. So this is equal to 30 boys plus 20 boys is equal to 50 boys. And one boy does how much? 1 by 200 of the work. So 50 boys will do 50 into 1 by 200 of the work, which is equal to 50. 1s are 4s are. So 1 by 4 of the work. 50 boys will do 1 by 4th of the work. That means to complete entire work, they take 4 days. So 50 boys will take, or 50 boys means 15 men and 20 boys. They will take 4 days to complete the full work. Because in one day they do 1 by 4th of the work. So in 4 days they can complete full work. Answer is